Welcome to this course, Machine Learning for All, and we are in the topic 5. So here we will be showing you the demo for these two previous algorithms. That one is K-means clustering algorithm, another is the association rule mining with the help of Python. So first we will be implementing K-means algorithm with the help of Python. So the same platform we are choosing, that is Google Colab, because it is widely available for everyone, and definitely there is a very less headache for installing any kind of your libraries that is useful for machine learning applications. So let us first open the Google Colab notebook for Python and just rename it. If I just rename it that K-means. So okay, I'm just writing it K_means. Okay, and I'm just writing ML, machine learning for all, MLA. So what if I have to do? First of all, I have to go and connect my Google Drive, because within the Google Drive I have stored my data. So you have to just call your Google Drive. So it will take little bit time to connect. So meanwhile, while it is connecting to my drive, so let us just write all the necessary libraries for this coding. So first you have to just import pandas as PD. Then we have to go or we have to call the sklearn, basically that is related to your machine learning library. So from sklearn dot cluster import K-means. So just remember, you have to always remember this name, that K-means, from sklearn.clusters. So otherwise, if you're just writing with without caps, then it will be a wrong thing. So so next from sklearn we have to just calculate the Shillert, or call the Shillert score. So from sklearn import Shillert score. So again, you can get this kind of help from the Google Colab. Already it is kind of predicting or trying to suggest you some of the code. So it will be very much helpful to you. Now we will do some manipulation in the number. So I need numpy import as np. So once you have all the libraries, so if you just hit, so all these libraries are now with you. Now here because I have to connect with my Google Drive, so already it is there. So then what I have to add, I have to just add a code with this. So I can go to the code. Now here actually you are just calling the deciding or defining your data frame. So df, again you have to write pd dot read underscore excel, and within the bracket I have to just mention the address. So here in the drive I have created separate folder of machine learning for all. So I have to just find out that particular folder. Within that I have a data. So here on the 3 dot, if you just click, so you have copy path. So once you copy path, so put or paste this path, and then what do you do? If you just put df.head and you just print it, So you can just observe the top 5 or the rows for the particular movie. Now from here also you can find out what are the features or what are the information available inside your data. So first column it shows the movie name, second column is BOC or box office collection, second column is success or failure, then budget, views, likes and dislikes. Now let us just change this approach this time. So in Excel we consider only BOC, budget, views, likes and dislike. Now in place of that, why don't we are using, now this time we are using budget, views, likes and dislike for clustering, and just check what is happening. So again I'm just adding the code. So there we did kind of a standardization of the data. So here also we will try to do kind of a standardization of the data. So for that, from again I need to just call sklearn, another pre-processing actually library. Then I have to just define the number of or the particular. So let us just put this thing in the initial stage. So all the libraries will be there in a single cell or single row. So here only what I will do, I will just implement the scaling. So features, first of all I have to just mention features, then within that I have to just define all the useful features. Let's say here I'm just using only budget, then views, then likes and dislikes. And I'm just doing a scaling of the data. So these are the x variable x, so I have to tell that okay these are the variables, so x equal to bf, then within the features I have to just mention features, and I have to just scale it equal to standard scaler SCA, and then x underscore scaled equal to SCA scalar dot fit underscore transform, and within the bracket you have to just mention the set of variables. So as it is again dependent on the internet connection, so based on that only it will just try to connect. Okay, so it is done. So I have to go to the next part. Next part is nothing but you have to just print, you have to create the cluster. So k means model, I'm just naming it k means model underscore model equal to k means. So within n cluster, so this n cluster is nothing but how many clusters you are actually you want to create, that you have to define over here. Let's say I'm just creating 2 clusters over here, and again a random state equal to 42, and then go for clustering clusters equal to, so you have to just again call the model k-means underscore model, then dot fit underscore predict x scaled, then you have to again hit enter. So again it will take some time based on the internet connection or internet speed. So here what happens, see all my models, actually I have to run them all. So I run them all. So I created my cluster model. Now what I have to do, I have to just calculate my scores. So here another thing, I have to just check df clusters. So because I need to store them into a particular variable, that is cluster. So here I am just storing all the particular instances into the cluster variable with the help of this cluster. Okay. Then next we will go for calculating our performance or quality cluster quality measurement, that is Shillite score. So here underscore score, so that I have to just calculate based on your x underscore scaled and your cluster information. And then you have to just print these values. So if I just print SILHOU Shillite score, SCR score, and then you have to just call the particular variable where you have stored your Shillite value. So I'm just copying the name of that particular variable where I have calculated the value of Shillite. And then if you just hit enter, so here we have calculated first of all we have just fitted our model. So basically we have implemented our k-means algorithm with cluster number 2 into the and we have created with the help of the available data, and then we are trying to save all this information within this data frame called clusters. And after calculation of this or creating the cluster, we have to just evaluate what is the quality of the clusters. In that case, we have used the Shillite score. So now already we have called, let's say here, just check that from sklearn.metrics import Shillite score. So from with the help of this Shillite score, we are trying to evaluate our clustering quality. So here our calculated value is 0.720495. So you can roughly say 0.7. Now what we will do, now we will go and just calculate our, so here I'm just putting a note, evaluation of cluster quality with the help of Shillard score. So again, I'm just for understanding purpose, I'm just repeating what is Shillard score. Shillard score is nothing but a metric which helps you to understand how a particular member in a particular cluster is near to its centroid and how far it is from its nearest cluster centroid. So it indicates how much it is similar to the members, and also it indicates how much it is dissimilar to the nearest cluster components. So next we will calculate the SSE within cluster SSE and between cluster SSE. So this is another measurement of measurement for understanding how the cluster is formulated or how the cluster is generated. So basically again another cluster evaluation approach. So I'm just adding another code. So here I'm just writing simply, I'm just putting a note, evaluate the cluster quality with the help of sum of square, SS sum of square within and sum of square between. So here what you can do, you can first define a variable which will actually store the within cluster SSE. So I'm just writing within underscore cluster underscore SSE equal to k means underscore model dot inertia. Okay, so I have to just k means model. So what name I have just defined? So this is the name. So I have to just copy paste same name over here. Otherwise, okay. So this is the model name. Okay, now it's the same name. So then what I have to do, I have to just print this value over there. So I can straight away just write print and go to the within. So it is already suggesting within cluster SSE, and then you just put the value or the variable, the same variable what you have defined. So I'm just copy paste the same name. And if you just hit, so again, okay, so there is a problem. So what I have to do, I have to just put a comma. So here is a syntax mistakes. Okay, so this is 298. Now next what we will calculate, we will just calculate the between the clusters. So in that case, you have to first calculate the overall mean, then only you can calculate the total SSE. So overall mean equal to just np dot mean, and you have the scale value, so that x underscore scaled comma xs equal to 0. So already it is suggesting that same syntax, and then total SSE equal to np dot sum bracket, just write x scaled minus overall mean, and then just take the square of it. So in that case I have to just use star 2. So this will do kind of a square of this entire term. So now how to calculate the between? So if I just between underscore SSE cluster to SSE cluster underscore SSE, it will be the total minus your within cluster SSE. So total, so we have already calculated the total SSE. So you just take this total SSE, control C, minus, okay, control Z. So total again I have to total underscore SSE minus that within you have calculated, that thing you have to just mention. So within cluster underscore SSE, and just print this same value, print between cluster SSE comma and the particular variable name. So if I hit enter, so okay, so something is wrong. Okay, this is access. So this will be access. Okay, so I have this within class SSE and between class SSE. Now let's say if you wants to create another model. Let's say again I'm just considering the same value and creating another model of clustering with the help of, let's say, 3 clusters. So if I go there, and now I'm just giving a name to it. So let's say if I just model, and this is model underscore 3, it will indicate the number of 3 clusters are there. And again rerun or redo the thing. So here I'm just putting cluster generate 3 clusters, 3 clusters. Okay, and you have to do the same thing, means twice you have to just run the same mod, same set of code. So here my model, so what happens here, I have to just give a name to new name. So definitely the model name, I'm just giving underscore 1. So this will also be underscore 1. This will be underscore 1. And here also underscore 1. And if I just run this, okay, so there is cluster 1 is not defined, so I have to just run this thing, then only it will work. Okay, so here my CLOID score is 0.72, there was a 0.72, so there nothing much change into it after running this. So now what I can do, I can again just go to the SSE and SSB and SSC calculation, or within SSW calculation rather. So here I'm just trying for 3 clusters. Let us just check whether any kind of changes are there or not. So here also I'm just putting within cluster SSC, I'm just naming same, but the model name will be different. So again, let us just run. So okay, because I haven't changed the variable name, so it is showing the same result. Okay, so this model was k. Okay, this here only I have to just change it. K means underscore model underscore 3, so it was 3, and then overall mean between cluster SSC. Okay, now let us just run this. Okay, K means object has no attribute inertia underscore, so or rather in the same code we can check. So let us just change this to 3. Twice we will run. So this is, see, the value is changed to 0.50. Again it is 184.15. So from here also we can check that how the cluster characteristics has changed. So the Shillard score here it is 0.50, which is not good, because let's say based on the formula it should go up. So in that case, the previous with 2 cluster, the solution was better. So again I'm just running the same thing with 2 cluster, just check it is 0.72, and also but in this case of your SSE and SSW, so here I have to just change SSW, the values are a little bit varying. Again here it is 298, 297, but in the previous case it was 180 and 297. So you can say that that previous result based on the cluster sum of square, it was giving within sum of square it was better result, but somehow away or in a between the clusters it was not producing that much improved result. So definitely with the help of this Shillard score and your within cluster or between cluster SSE, you can easily understand how well you have clustered, or the how well or the quality of the clusters when you are implementing multiple clustering options. So now maybe the question is that okay, so in case of let's say k-means, you have to just predefine the number of clusters, but with the help of elbow curve or this SSC and SSW calculation, you can easily identify what is the number of optimal curve. In that case, it will generate a elbow curve. Basically, if you plot the SSC value with respect to the number of clusters, then it will show kind of a elbow type of graph, based on which you can easily identify the optimal number of clusters. But by the way, that is not a scope of this course. So we are here to understand the basics of basics of clustering. So here is a demo of how you can generate 2 or 3 or predefined number of cluster with the help of k-means algorithm in the Google Colab platform with the help of Python coding. So hope you understood how cluster works, and maybe this can be very much useful for your application if you are applying this kind of method in any kind of grouping or segmentation type of problems. So thank you. Thank you for watching this video, and definitely next is association rule mining. So hope you will be enjoying that video also. Thank you.